Welcome to Statistics Learning Session. Today we'll be talking about assumptive test. What is this assumptive test? It is a hypothesis test that follows from our previous lecture about about hypothesis testing that was done to see whether a medicine is better than placebo. In our previous lecture, we talked about an expression that was near normal, that is x n minus y n minus delta d minus delta c divided by delta square c divided by n delta square d divided by m. The problem was with this expression was that we didn't know what a or true delta c and true delta d were. For that we need a substitute of those values. How do you do that? We can do that using a program or a lemma called Slusky. Let me make some correction here. This is a lemma that helps us to substitute these values with sample average. And when we do that, we'll get an expression that we can use in daily life to compute whatever we need to test. So before we move on, let me present you with an expression that will help us to get to the Slutki's expression. And that expression is called continuous mapping theorem. What continuous mapping theorem says is that if I have a delta d n delta dn and delta cm square, we have these two squares. Divided by m. We have this expression, and this expression is supposed to go to 1 when n goes to infinity. And why we say it just n goes to infinity without mentioning m? Because n m are related, because n is equal to m by c. For that reason, we just say if n goes to infinity, then this goes to 1. Let me further break it down. Now let me multiply this expression by n and m. What will happen? Let me see. Square root of n and square root of n, and multiply by delta square d delta square m, and let's multiply copy the same expression. What will happen if I multiply these two? Let me show you. if you multiply this, then it's going to be delta square D plus delta square C by C D, and the denominator expression will be hat delta D square plus delta C hat C. This will be the expression, and this expression will eventually lead to 1 will eventually lead to 1 when n goes to infinity. When n goes to infinity, it will eventually lead to 1, and here delta hat D square is calculated using this value, and delta hat C square will be calculated using this value. Now, once we know that once we know that hmm, once we know that it eventually leads to 1, what we can do is we can multiply this expression with this expression here, and it will lead to cancellation of this expression by this expression, where we will ultimately have this value left, this expression left, y square xn minus ym hat delta d minus delta c divided by square root hat d n plus delta c square root m, which will eventually lead to normal value or normal distribution. So that's all for today. Let me quickly summarize what we learned today. Let me summarize what we learned today, starting with the asymptotic test. We talked about asymptotic test, and we started from our last lecture where we had an expression that had delta c square and delta d square, but we didn't know the value of those. Therefore, we used a continuous mapping theorem to get to an expression where we can use delta hat d square and delta hat c square, and which can be used by calculating from sample values. And then we came up with an expression that can be used to test a hypothesis. That's all for today. I will see you next learning session. Thank you so much.